Welcome back to the deep dive. Now, if you're currently wading through ATPL theory, maybe specifically staring down the barrel of flight planning calculations, then today is definitely for you. We're doing a really intensive review of the EASA Fuel Policy.
That's right. We're focusing hard on the calculations, those specific numbers, the rules you absolutely need to have locked down for the exams.
Exactly. The mission today isn't just to rehash the rules, but to really distill that core knowledge. You know, the fixed times, the percentages, the definition.
And nuggets of knowledge, yeah.
The things that let you answer those fuel load questions accurately, whatever scenario they throw at you. We're pulling this straight from the official policy breakdowns and a pretty detailed calculation example we'll walk through.
Think of it as translating that dense regulatory text into something, well, sticky, memorable.
And look, we always say this, but it bears repeating. This isn't just about passing an exam. These rules, the ones laid down in CSOPS 1.
Certifications, specifications for operational safety, yeah.
They're absolutely fundamental to safe flying. Get the fuel wrong at the planning stage, and you're potentially compromising the whole operation before you even leave the gate.
Couldn't agree more. So let's start right at the beginning, shall we? Before we calculate the total fuel we need to load the block fuel or ramp fuel, we have to understand the different categories of fuel we're required legally to carry.
Okay, let's unpack the most basic one first. Trip fuel. Seems simple enough, right? Fuel for the trip. But the ESI policy insists it has to be a realistic figure. What does realistic actually mean here?
Realistic means you're accounting for, well, everything. Every phase of the actual flight as it's likely to happen, not just some idealized cruise. It starts right there on the ground.
Okay, so like startup, taxi fuel.
Exactly. Startup allowance, taxiing out to the runway. Then, crucially, all the maneuvering ATC is likely to give you.
Ah, so the standard instrument departures, the SIDs, the climb itself, the cruise.
Yes, the whole cruise segment, from top of climb right through to top of descent. And that must include any planned step climbs, any changes in altitude.
Right.
And then you can't forget the descent, the arrival procedures, those stars, and the actual approach and landing at your destination. The policy is clear. If ATC typically vectors you way off track on a star,
which happens,
that extra fuel burn has to be planned for within the trip fuel figure.
Yeah.
It can't just be wishful thinking.
Makes perfect sense. The plan needs to mirror what actually happens out there. The sources also stress that this calculation has to factor in expected weather and the aircraft's weight, doesn't it?
Oh, absolutely. If you're expecting stronger headwinds or maybe icing conditions that require anti-ice systems,
we can burn more fuel.
Exactly. That higher consumption has to be built in. Same goes for weight. A heavier aircraft, maybe operating near its maximum takeoff weight, is naturally going to burn more fuel, especially during the climb. So the final trip fuel number has to stand up to scrutiny against all those anticipated conditions.
Okay. So once we've nailed down that realistic trip fuel figure, we can start building up the total block fuel. Let's list those components again, just to be clear.
Right. There are basically 4 key pillars that make up that total mandatory fuel load required by law.
First up, taxi fuel. What generally dictates how much this is it just moving from A to B on the ground?
Well, it covers the engine start, the taxi itself, but also essential things before you push back. Running the auxiliary power unit, the APU.
Ah, for air conditioning and power while parked.
Exactly. That APU is essentially a small jet engine, and it's burning fuel while you're boarding passengers getting ready. You know, that figure often quoted, like 260 kilos for a 737.
Yeah, I've seen that.
That's typical for a busy airport because it might cover, say, 15, 20 minutes of APU runtime plus potentially long taxi times if you're stuck in a queue at Heathrow or Frankfurt.
You'll need that buffer.
You definitely will.
Okay, component number 2 is obviously the trip fuel we just spent time defining.
Correct. Realistic trip fuel.
Then number 3, the big one, reserves. This is where it gets complicated, right? With subdivisions.
This is the critical category, yes, especially for exams. It's broken down into contingency fuel, alternate fuel, final reserve fuel, and sometimes additional fuel.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best